Hey Opties! Today we're talking about one of my favorite things to talk about in geometry at the beginning, because I have a few ways that I think are really fun to remember the rule for vertical angles. So one of them is, when I was a kid, I really liked this movie called Jump In. It had Corbin Bleu and Keke Palmer. They're super awesome, and it was about jump roping and boxing. So they had this song that played there, and it was like this. You ready? Going vertical. And this makes me think about vertical angles. And I think it says something else like, straight to the sky, right? Like a miracle, something like that. I don't know if it says straight to the sky. You know how you make up lyrics in your head? Yeah, that might be what I was doing. But this is what I like to do. I like to put my arms like this, because vertical angles happen where you have intersecting lines, and vertical angles are angles that are across from each other in intersecting lines. So these two angles are vertical angles, and so are these. Even though these aren't actually looking like they're vertical because they're side by side, more like horizontal, they're still called vertical angles. Just think about it. You could tilt them and make them vertical to each other. But these are vertical angles. So if you really want to have some fun and remember, do this. Going vertical, or going vertical. It doesn't matter where you start, as long as you know these are vertical to each other and these are vertical to each other. The other way I find it pretty fun to remember is some scissors. Just kidding, some scissors. And I do have a scissors icon there. And I didn't think about this till recently, but I feel like scissors are a perfect representation of vertical angles theorem. Watch this. The bottom and the top open up the same amount at the same time. The point of intersection is right here. That's where they're linked together, right? That's like their hinge. And if I close them, the top and the bottom close at the same time. So these guys close, that was scary. These guys close, and this touches this at the same time that these close. So here's the deal with vertical angles. They are always congruent, meaning they're always equal in measure. So think about this. As I close my hands, the bottom of my arms also close. They're always closing and opening at the same amount. So vertical angles are always congruent. Let's take a look at the written out version of this. Vertical angles theorem. Angles that are opposite each other and formed by two intersecting straight lines and are congruent. So they're congruent, and the way you have vertical angles is they're opposite and they're created by any two intersecting lines. Technically you can have rays or segments as well, but typically we talk about it with lines. Let's take a look at our image. We see here that we have line M and its intersecting line N. We know they're intersecting because they cross each other. That's what intersecting means. We have angle markings to show congruence between angle A and C, which are vertical angles because they're across from each other or opposite each other in these intersecting lines. And we see that D and B are congruent angles because of their both having double angle markings. And they're also vertical angles to each other because they're opposite in intersecting lines. So let's look at our given information. Line M and line N are intersecting. So not only do we see it in our picture, but it's also told to us. Therefore, because they're intersecting, we know which ones are vertical angles because of them being opposite, and we know that angle A is congruent to angle C. So these one angle markings, the orange angle markings, and angle D is congruent to angle B, both with the double green angle markings. Let's take a look at the proof of the vertical angles theorem. A proof in geometry, or really anywhere in math, is when you take some sort of assumption and you go about listing everything you know about that to be true, like what it is and why it's true, so the statements and the reasons, and then you arrive at some sort of conclusion. And that's the thing you would be proving, whatever your conclusion is. So let's take a look at our point to ponder. In a proof, always start with listing 1, the given information, and 2, what you need to show. I like to call need to show an NTS. It's easy to write, and when we say we always list given first, in a proof we're actually basically making bullet points. Now this is one way to organize a proof. With a 2-column proof, as we call it, like a table. We have statements on the left and reasons on the right. This is not the only way you can do a proof. You can also just write a big old paragraph. That's completely fine. If I personally was going to do a proof, I probably would write a paragraph. But it's great to use this statements and reasons 2-column proof because it's very organized and it allows you to kind of make bullet points. And that way you know there is a reason for every single statement that you're making. So let's look at our given information. And again, we're going to start with that. That's going to be our first statement, always. And the reason for that will always be given. So always start with your given info. So line M and line N are intersecting. We want to prove that angle A and angle C are vertical angles. So what's true about vertical angles? Above, we found out that it's true that vertical angles are always congruent, which means they have equal measure. So that's what our need to show is. So let's write that. We need to show that the measure of angle A is equal to the measure of angle C, and furthermore, that angle A is congruent to angle C. Okay, so let's go about proving it. We always start with what's given. So line M and line N are intersecting. So let's just write that. Line M and N are intersecting. The reason is that it's given. A lot of times you will need to write a proof from scratch, but since it's our first proof we're ever doing, I've put in lots of things already and we're really just filling in the blanks. Our second statement is angle A and angle B are a linear pair, and that is something that's already written for us. We have to think about what's the reasoning for that. Well, let's look at our picture. A and B are a linear pair. A linear pair means you have 2 angles that when you add up their measures, they equal 180 degrees. Notice A and B make up line M. If you put them both together, they are going to be the 180 degrees that creates this line M's angle of 180 degrees. So that's our reasoning. So we're going to say angle A and angle B make up line M. Because you know a line, that's a straight angle and that's always 180 degrees. So that's how you know you're supplementary. And furthermore, a linear pair because it's just 2 angles. You could also just say they're supplementary, but the most specific way of saying it is that it's a linear pair. We have a third reason given to us. Angle C and angle B make up line N. Notice that this is very similar to what we wrote for our reason above. Angle A and angle B make up line M. So C and B making up line N, let's look at our picture. C and B, if you put those together, they're going to make up this orange line, which is line N. So we're going to say that C and B form a linear pair. So that's what our statement's going to be. Angle C and angle B form a linear pair. You can also just write are a linear pair like it says here, but you can write form a linear pair, it's fine. Our next section, we have actually both of those filled in for us. Let's take a look. The measure of angle A plus the measure of angle B is 180. Well, isn't that the definition of a linear pair? That you're adding up to 180? Well, yeah, and that's our reason. So we said the similar statement that goes along with this next thing we had written for our statements, that C and B are a linear pair. And that reads the measure of angle C plus the measure of angle B is 180 degrees. So both of those are because the fact that they're linear pairs. So notice we already talked about how they're a linear pair, and then we started talking about what that means. So you have to go in a certain order. There are different orders you could take, but order does matter here. Let's take a look and see what has changed between this line, so our fourth line, and this line, which is our fifth line of statements. We have solved each of these equations for the measure of angle A and then the measure of angle C. Let's take a look at what both of these equations now equal. The measure of angle A is 180 minus the measure of angle B. The measure of angle C is 180 minus the measure of angle B. They equal the same thing. We did that on purpose, so we chose A and B and then B and C on purpose so we could have this B overlapping, and we could show that A and C are equal to each other by taking out the measure of angle B. So if they both have a sum of 180 and you take out that B, then it shows that A and C are going to be equivalent. So that's where we're going to get to in just a moment. So how do we get from lines 4 to 5 in our statements? We just subtracted. We subtracted the measure of angle B from both sides. That's all we did. So we can just say subtraction and we can say we did minus the measure of angle B from both sides. You don't have to say it like this. You don't have to actually list that, but that's a good tell for us to remember this is what we actually did. Sometimes you will also see it written as subtraction property. That's really just a super fancy way of just saying you're subtracting. So if you see that, it just simply means you're subtracting. We have two more things to fill in. The next one is a statement. So let's figure out what our statement is by looking at the reasons. This one is kind of so incredibly obvious that you're like, why do I even have to say this? But you do need to say this in order for us to claim that 180 minus the measure of angle B does equal 180 minus the measure of angle B. So the reflexive property of equivalence, and POE just means property of equivalence. That means one thing equals the same thing. So here's what we're going to write here. The measure of angle B equals the measure of angle B. They equal each other, and because of this we can claim now that the measure of angle A equals the measure of angle C because they're both equal to 180 minus the measure of angle B. So that's what our last thing's going to be. We've now proved that angle A and angle C are vertical angles. So let's write Y, and it's going to be both of these guys. So the measure of angle A is equal to the measure of angle C. And we might even potentially write another line saying, oh, the angle A is congruent to angle C, and that's because of the definition of congruence or something like that. But it's up to interpretation whether you actually need that or not. So we'll just write it here. Angle A is congruent to angle C. And we're done because we've accomplished our need to show. Remember, vertical angles are always congruent. So we've shown that, and now we're done with our proof. That's it for our vertical angles notes. Next, we're going to talk about vertical angles practice. See y'all next time.